Hi friends, Naimar here again from Factorial Biomechanics. I'm super excited today because we're introducing your biomechanics assistant. We're doing a demo with jumps. Here I'm anonymizing to avoid distractions. The video has 3 jumps which are clearly visible in the graph. I'm going to isolate the center of mass trace on the left foot index, which has the clearest trace. Then I'm going to make notes denoting the takeoff and touchdown of each one of the jumps. We're using computer vision to analyze the graphs, so we need to make sure to turn on the traces we're paying close attention to and turn off the ones that we're not using to avoid noise. Your biomechanics assistant can see the graph and help you make sense of them in different ways, automating summary tables, making additional calculations. That's why by default we include the X and Y coordinates, which include timestamps for each point in the notes. Here I'm trimming the video by dragging the endpoints closer to the action. Since I'm analyzing jumps, I'm going to ask my assistant to calculate airtime from the selected points in the vertical displacement graph. And I'm telling the model to use the center of mass and left foot index trace for that task. Here we can see the 3 sets of numbers. I'm asking it to put it in table format to visualize it better. Now I'm annotating the lowest point of the center of mass prior to each one of the jumps to isolate the pushing time, which will help us later calculate power. I'm asking the assistant to calculate the height of the jump by using the vertical ballistic equation. It can do general physics calculations, taking into consideration the flight time and gravity as a constant. It's like a contact mat now. Now I'm asking it to take into consideration the pushing time that I just marked in the graph so that we can get power calculations and compare it across jumps. I would like this information in table format so I can directly ask it for it. When I ask it to calculate power, it tells me that we require more information, either force or mass. So I input the subject's weight, which is 198 pounds. Then the output's ready, with all the steps taken to achieve the final numbers, including converting to kilograms and the formulas that were used. It's showing me 600 watts for the first jump and how each jump after that has a little bit less power than the previous one. I decided to dive a little deeper into the conversation to learn about how analyzing power over different repetitions can help us evaluate variability in an athlete and aid in identifying fatigue, and how that can help us prevent injuries and optimize return to play times.